Hello guys, and welcome back to the next part of our lesson. For this part I wanted to show you how we can use a function machine to help us solve some of these word problems. So this one here here is a rule for the time it takes to cook a chicken. Cooking time equals 20 minutes plus an extra 40 minutes for each kilogram. How many minutes will it take to cook a 3 kilogram chicken? Okay, so I'm going to set up my function machine for this, and it takes 40 minutes for each kilogram. So my input is going to be the weight of the chicken. So I have my input, which is going to be my weight, on my output, which is going to be the length of time. And I know I put the weight of my chicken in, and then I have to do it times 40, because it says 40 minutes for each kilogram. And then I have to add on 20 to get the total time that it takes to cook a chicken. Now the first part of the question says to me, or asks me to work out how long it takes, how many minutes it takes to cook a 3 kilogram chicken. So I've got my 3 kilograms here. That's my input, is my 3 kilogram. I need to work out what my output is. So 3 times 40, well 3 times 4 is 12, so 3 times 40 must be 120, plus 20 is 140. And it asks me for my time in minutes, so I can just leave that as minutes. The second part of the question, we've got the same function machine as we had for the first part, is I know that the total time is 100 minutes. So I know that the time is 100 minutes. I'm going to put time in here just to make that clear. Remember what I said earlier about the fact that when we're working backwards, we need to use the inverse. So I've got 100, take away 20 would be 80. Okay, 80 divided by 40 is 2. So the weight of a chicken that takes 100 minutes is 2 kilograms. Let's just double check going the sort of left to right. So 2 kilograms, 2 times 40 would be 80, plus 20 equals 100. The key thing with this question, because up here you might be tempted to put the plus 20 first. But if we did the plus 20 first and then multiplied, we wouldn't get the same answer, would we, which from what we saw before. So you need to think about the order in which you need to do it before you put your function machine together. Have a look at this next question for me. Maria bakes cakes and sells them in bags. She uses this formula to work out how much to charge for one bag of cakes. The cost equals the number of cakes times 20 plus 15p for the bag. How much will a bag of 12 cakes cost? Have a go at drawing a function machine for this question. What would that look like? What does your input relate to and what does your output relate to? Pause the video, have a go, and then restart when you're ready to go through the answer together. Hello guys, welcome back. So the key thing, like with the previous question, is working out what goes first. So the first thing we need to do is multiply the number of cakes by 20 pence. It's 20p per cake. And then it's just one flat fee of £15. Doesn't matter how many cakes you buy, you just pay the 15p once. So that goes at the end. So in my function machine, I've got my 12 cakes going in. I'm timesing that by 20. Okay? Or 2 12s are 24. So 20 must be 240 or £2.40 plus 15, which would be £2.55. Okay. The second part of the question asks me if Olivia buys a bag of cakes for £5.15 to use this formula to calculate how many cakes are in the bag. Well, she spent £5.15, and remember, if I'm working backwards, I'm using the inverse. So rather than adding 15, I'm going to take 15 away. So £5.15 take away 15 would be £5. And rather than times my £5 by 20, I'm going to divide by 20. And I know that there are 5 20s in £1. 5 20 pences in £1, and I've got £5, so that must be 25 lots of 20. So the answer is 25 cakes. Okay, this question is a little bit more straightforward for you. It says this relationship connects the number of pencils and the number of boxes. So the number of pencils equals the number of boxes times 12. How many pencils are in 18 boxes? See if you can use a function machine to try and work this question out. Pause the video and then restart to go through the answer together. So here is my function machine. I put in the number of boxes, I multiply it by 12, and then my output is the number of pencils. Okay, so I'm going to do a column method for multiplication because I'm not entirely sure I can do that one mentally. So 2 times 8 is 16, 6 carry the 1. 1 times 2 is 2 plus 1 is 3. Then I'm going to be doing 10 times the number above, so my 0, 1 times 8 or 10 times 8 is 80. And 10 times 10 is 100, so 1 in the 100 column. Then I add the 2 together, 6, 8 plus 3 is 11, 1 carry the 1, and then 1 plus 1 is 2. So my output is 216 pencils. Okay, last question for you today. The numbers in this sequence increase by 45 each time. Write the missing numbers. Pause the video and see if you can use a function machine to help you calculate this question. And then switch back on to go through the answer together. Okay, hopefully you've drawn a function machine that looks a little bit like this. So, for the first bit, I'm trying to work out what this number is here. And I know the one before, the number I'm inputting is 245. And my rule is to increase by 45 each time, which means if I'm increasing, I'm adding on 45 each time. So my rule is plus 45. So 245 plus 45 is going to be 290. Now I want to know what this one is. So if I put, that's going to be my input now, the 290, the number that goes here, will be my input. If I add another 45 on, that's going to be 335, which will be the next number in the sequence. The tricky one might be this one here, because it's going to be lower, isn't it? So actually, rather than putting this as my input, the 155 becomes my output, because I want to know what the number below is. So again, I'm working backwards, so I'm going to do the inverse. So 155 take away 45. 5 take away 5 is 0. 5 take away 4 is 1. 1 take away nothing is 1. So my number there in that sequence is 110. I hope that it helps to see this as a function machine and show you that actually there are a lot of questions that you can use algebra to help you calculate. Speak to you soon. Bye.